Hi guys! Welcome once again to the Multimodality Learning Program of St. Mary's University Senior High School. We are now in the 6th week of our lesson on the derivatives of inverse trigonometric functions and implicit differentiation. Again, I am Miss Diana C. Hermoso, your basic calculus teacher. Our learning objectives for this session is to first, apply the differentiation rules in computing the derivative of inverse trigonometric functions. Second, to illustrate implicit differentiation. Here are the derivatives of inverse trigonometric functions, such as the derivative of inverse sine of x is equal to 1 all over square root of 1 minus x squared. The derivative of inverse cosine of x is equal to the negative of 1 all over square root of 1 minus x squared. Third, the derivative of inverse tan of x is equal to 1 all over 1 plus x squared. Next, the derivative of inverse cotangent of x is equal to negative 1 all over 1 plus x squared. Fifth, the derivative of the inverse of secant x is equal to 1 all over the absolute value of x multiplied by square root of x squared minus 1. Lastly, the derivative of inverse cosecant of x is equal to negative 1 all over the absolute value of x multiplied by square root of x squared minus 1. So, ito yung mga kailangan nating i-take note for our succeeding examples. Okay, first example, what is the derivative of y equals the inverse of sine x minus the inverse of cosine x? For our given function, first, identify the derivative of the first expression. For this video and the following video, we shall denote the derivative. So instead of f prime of x, we shall denote the derivative as d all over dx. Of first, we have inverse sine of x minus d all over dx, again, derivative of cosine or inverse cosine of x. Next, evaluate the derivative of inverse sine x, which is equal to, again, y prime. Y prime is equal to, we have d all over dx of sine is equal to 1 all over the square root of 1 minus x squared. Next, the derivative of the inverse of cosine x is equal to, and so we have minus negative of 1 all over square root of 1 minus x squared. Next, since we have our operation which is subtraction and the sign of the subtrahend is negative, we shall now change our operation to addition but change the sign of the subtrahend which becomes positive. Thereby, we have 1 all over 1 or square root of 1 minus x squared plus 1 all over square root of 1 minus x squared. Thereby, the derivative of y is equal to, we have 2 all over square root of 1 minus x squared. Ayan, so ito na yung final answer natin. Okay, so that is our first example. Okay, second example. The given function is y equals 1 minus the inverse tangent of x squared. So for this example, we can first expand our binomial. So that is 1 minus the inverse tangent of x multiplied by 1 minus the inverse tangent of x, which means that multiply first term. So we have 1. Next, 1 times negative of inverse sine of tangent x is equal to minus inverse tangent of x. Next, we have negative tangent or inverse tangent of x times 1 is negative inverse tangent of x, and then negative inverse tangent of x multiplied by the negative inverse tangent of x is equal to positive. We have inverse tangent of x and squared, which means that we have to differentiate 1, a negative inverse tangent of x minus inverse tangent of x is negative 2 inverse tangent of x plus we have inverse tangent of x and then you have squared. Therefore, we have to differentiate each of the terms in the expanded form, such as first, what is the derivative of a constant? So we have constant is equal to 0. Okay, next, differentiate. So we have differentiate d all over dx to inverse tangent of x and of course d all over dx of the square of inverse tangent of x. So we have squared in our expression. Okay, for our second terms, we have y prime is equal to, tanggalin na natin yung 0. Okay, for the derivative of 2 inverse tangent of x, we have our constant multiple which is equal to 2. So we have negative 2 multiplied by the derivative of inverse tangent of x, which is equal to 1 all over 1 plus x squared. So that is the derivative of the first or our second term. Next, we proceed with the derivative of inverse tangent of x squared. So we have, let your function, we assign it as f of x is equal to the inverse tangent of x squared. And since this can be expressed using u, so we have u is equal to the inverse tangent of x. And we have said that the inverse tangent, derivative of inverse tangent is equal to 1 all over 1 plus x squared. Therefore, in our function, f of x can be written as u squared. And the derivative of the given function will be equal to, we have 2u multiplied by the derivative of u, which means that that is equal to 2 multiplied by u, which is the inverse tangent of x, multiplied by the derivative of u, which is further equal to 1 all over 1 plus x squared. And then simplifying our given expression, that is equal to 2 inverse tangent of x all over 1 plus x squared. So that is the derivative of the last term. So we can now add, we have plus, the derivative of this whole expression is, we have 2 inverse tangent of x all over 1 plus x squared. So we have 2 inverse tangent of x all over 1 plus x squared. And then simplifying, we have negative 2 times 1 is equal to negative 2 all over 1 plus x squared, plus we have 2 multiplied by the inverse tangent of x all over 1 plus x squared. Since these are similar fractions, we can combine them as equal to negative 2 plus 2 inverse tangent of x all over the common denominator, which is 1 plus x squared. Therefore, this is now y prime. Okay, we proceed to our third example. Given the function y is equal to x all over inverse sine of x. Given our example, we can assign our numerator as f and denominator as g, since this is a ratio or that is performed by the division operation, which means that if f is equal to x, f prime of x is equal to, we have derivative of x, which is equal to 1. Next, if g is equal to inverse sine of x, therefore g prime of x is now equal to the derivative of inverse sine, 1 all over the square root of 1 minus x squared. Next, evaluate then the derivative of y, which is equal to, sabi natin yung quotient rule, we have g f prime minus f g prime all over g squared. Next, substituting our given, ito yung mga given natin, we have g which is equal to the inverse sine of x multiplied by the derivative of the numerator, which is equal to 1, minus the numerator, which is x, multiplied by the derivative of the denominator, which is 1 all over the square root of 1 minus x squared, all over the denominator, which is the inverse sine of x and squared. Next, simplify the numerator. We have 1 times inverse sine of x is equal to inverse sine of x. Next, x multiplied by 1 all over square root of 1 minus x is equal to negative x all over the square root of 1 minus x squared. Of course, all over denominator, which is the square root of the inverse sine of x. Okay, next, simplifying, since the denominator of the first expression in the numerator is 1, we can have the square root of 1 minus x squared as our common denominator. So we continue on this part. So we have is equal to the common denominator in the numerator, which is 1 minus x squared. And 1 minus x squared divided by 1 times sine or inverse sine of x is we have, pwede nating unahin yung denominator bago yung inverse sine of x. So for example, we have the square root of 1 minus x squared multiplied by the inverse sine of x. Ayan. So ito na yung buong expression natin sa first term. Next, square root of 1 minus x squared divided by 1 square root of 1 minus x squared is equal to 1. 1 times the negative of x is equal to negative x. Of course, divided by still our denominator, which is the square of the inverse sine of x. Next, since we can change our operation to multiplication but get the reciprocal, so we can have square root of 1 minus x squared multiplied by the inverse sine of x minus x all over the whole denominator. So ito mapupunta sa denominator. We have the square root of 1 minus x squared multiplied by, we have sine inverse of x and then squared. So we can have our final answer as this one. Therefore, given y is equal to x all over inverse sine of x, the derivative is this expression. So, itong expression na yan. Next, we have number 4. Given f of x is equal to arc tangent of e raised to 4x. For this expression, pag sinabi nating arc tangent, that is still equal to the inverse of tangent. So, we have inverse tan of e raised to 4x. Ayan. So, ito po yung kukunin natin ng derivative. Now, for this function, we assign u as equal to itong expression na nasa loob ng inverse tangent, which is e raised to 4x. Next, get the derivative of u, which is, we have du, which is, we have e raised to 4x. Again, remember from our chain rule, kapag yung expression natin sa exponent is not equal to x, we need to get the derivative of that exponent. So, for example, since the expression is 4x, the derivative is equal to 4. So, yung e raised to 4x, i-multiply pa natin yan ng 4. Therefore, the derivative of u is equal to 4e raised to 4x. Therefore, given our function that is arc tangent of e raised to x, that is also equivalent to tangent or inverse tangent of u. Bakit anong nangyari dyan? Again, this expression is equal to the inverse tangent of e raised to 4x. Let u be equal to e raised to 4x. Therefore, if we're to solve for f prime of x, that will be equal to the derivative of inverse tangent of u dx or du. So we have d all over du of the inverse tangent of u multiplied by du, which means that what is the derivative of the inverse tangent of u? Okay, that is equal to, the derivative is 1 all over 1 plus u squared. So, in terms of u po tayo. Multiplied by the derivative of u. Ano ba yung derivative ng u natin? So, itong part na yan, multiplied by 4 times e raised to 4x. Next, since u, babalik tayo, since u is equal to e raised to 4, that becomes 1 all over 1 plus e raised to 4x and then raised to the second power. Again, yung u, pinalitan natin ng e raised to 4x multiplied by 4e raised to 4x. Next, multiplying the numerator by 4 times e raised to 4x, that becomes 4 times e raised to 4x all over 1 plus, ayan, e squared daw natin yung e raised to 4x. Since by power or loss of exponent, that is power of a power, i-multiply natin yung 2 by 4x, which becomes e raised to 8x. So this is now f prime of x. Okay, so those are our examples for the derivative of inverse trigonometric function. Okay, we proceed to implicit differentiation. Ano ba tong implicit differentiation? Now, given the equation y is equal to f of x, ito yung ginagamit natin usually, it is defined explicitly in terms of x. Now, not all functions are defined explicitly. Take for example the equation of our circle. We have x squared plus y squared is equal to 4. From pre-calculus, this is an equation of a circle. However, this equation is not a function. Not a function siya. General mathematics, vertical line test yan, hindi niya masasatisfy yung one-point intersection with the vertical line. But of course, we can solve y in terms of x. And we can have two possible functions such as y is equal to the square root of 4 minus x squared and y equals negative square root of 4 minus x squared. Now, such function is defined implicitly. Again, pag implicit, we cannot express our function in terms of x. Now, implicit relation or function between x and y is defined as f of xy is equal to 0. Again, remember that since we cannot express the given function in terms of x, ang gagawin natin is we remain it as in terms of x and y. So, we equate it to 0. Now, again, for implicit differentiation, if a function f of x, ito yung implicit differentiation natin, is a combination of x and y, where y cannot be solved in terms of x, nor x in terms of y, then we can get the derivative of f of x and y as equal to 0 by implicit differentiation. So, yung mga previous examples natin, those are equations which are explicitly written in terms of x. Yung mga susunod na example natin, those are functions which are not expressly written in terms of x. Therefore, gagamit tayo ng implicit differentiation. Now, in implicit differentiation, it follows the usual differentiation, yung mga rules natin, pwede natin gamitin for x and y. But there is an exception. Now, it follows y prime upon differentiating the variable y. So, ito po yung kaibahan natin. For implicit differentiation, after we differentiate the variable y, dinudugtungan po natin siya ng y prime in some references, or for this video, we shall use dy all over dx. So, ito po yung idudugtong natin. Halimbawa, ang derivative ng y will be equal to dy all over dx. So, ito po yung gagamitin natin. Okay, take for example, our first equation. X squared minus 2y squared is equal to 9. For implicit differentiation, kukunin natin yung derivative of each term. Halimbawa, d all over dx, again, derivative po yan, ng x squared. Next, d all over dx ng 2y squared is equal to d all over dx ng 9. Again, this symbol means that we differentiate each term. Next, kapag dinifferentiate natin at wala yung y, proceed with our usual differentiation such as, what is the derivative of x squared? So we have, derivative is 2x. Next, magde-differentiate na tayo ngayon ng terms with variable y. So for example, the derivative of 2y squared is just the same. We have 2 times 2 is equal to 4. Next, y, minusan natin ng 1 yung exponent. So we have raised to the first power. However, since we have differentiated a variable y, dudugtungan natin yan ng dy all over dx to show that we have differentiated terms with variable y. Okay, is equal to, again, what is the derivative of a constant? Okay, that automatically is 0. Next, ang second step natin dito is for us to express our equation in terms of x and y. So, ang susunod na gagawin natin, ipunin natin lahat ng terms with variable dy all over dx on the left side and all other terms in the right side. So, for example, since yung first term natin has no dy all over dx expression, ililipat natin yan sa right side. So, for example, ititira natin yung negative 4y dy all over dx, and then of course, by addition property, it becomes negative 2x. Next, lahat ng coefficient ng dy over dx, tatanggalin natin by way of division. So we have divide by negative 4y. kung anong dinivide natin sa left side, ganun din dapat sa right side. So we have negative 4y. Next, cancel negative 4y, so which remains negative or dy all over dx is equal to negative 2 all over negative 4 is 1/2. So we have 1 all over 2xy, or we have x all over 2y. Therefore, given this equation, the implicit derivative dy all over dx is equal to x all over 2y. Okay, next, we have x squared plus 4xy plus y squared is equal to 5. Just the same, we shall consider the derivative of each term. So we have x squared plus d all over dx of 4xy plus d all over dx of y squared is equal to d all over dx of 5. Next, by differentiation, ang derivative ng x squared is equal to 2x. Next, we differentiate 4xy. Remember that meron tayong dalawang variables dyan. We shall apply the product rule. So that is, first, we consider this our first term, yung 4x, and then we have second term that is y. So we have the first term, copy. So we have 4x multiplied by the derivative d all over dx ng second term. Again, this is our first term which is 4x and derivative of the second term. Ito yung product rule natin. Plus the second term which is y times the derivative d all over dx of the first term which is 4x. Again, this is, if this is f and this is g, that is f multiplied by the derivative of g plus g multiplied by the derivative of f. So yung part na yan. And of course, we have our derivative of the third term, which is, derivative ng y squared is equal to 2y. And since nag-differentiate tayo ng y, we have dy all over dx is equal to the derivative of a constant is equal to 0. Next, we have 2x. Next, plus, we have 4x. Derivative of y is equal to 1. However, nag-differentiate tayo ng y, kaya ang matitira is dy all over dx plus y, derivative of 4x is equal to the constant 4 plus 2y dy all over dx is equal to 0. Okay, next, combine all terms. Lahat ng terms with dy all over dx sa left, all other terms sa right. So we have 4x dy all over dx, and then plus 2y dy all over dx, and all other terms we have negative 2x, and of course 4 times y is positive 4y, transpose we have negative 4y. Next, on these first two terms, factor out dy all over dx. So we have dy all over dx multiplied by, pag tinanggal natin yung dy all over dx for both of the terms, we have 4x plus 2y is equal to negative 2x minus 4y. Of course, tanggalin natin yung coefficient ng dy all over dx, which means that we continue it here. Okay, so that is, divide both of the terms by, we have 4x plus 2y, and then of course, we have 4x plus 2y. And then cancel, we are left with the left side as dy all over dx is equal to, for our numerator, we can factor out negative 2 multiplied by x plus 2y. So, para natin check kung babalik tayo dyan. So, we have negative 2 times x is equal to negative 2x. Negative 2 times 2y is equal to negative 4y. All over, factor out the same 2. And then we have 4x divided by 2 is equal to 2x plus 2y divided by 2 is equal to y. Next, cancel common factor in the numerator and denominator. Therefore, dy all over dx is equal to the negative of x plus 2y all over 2x plus y. That is now our final answer. Third example. The equation is x squared multiplied by sine y is equal to 0. Okay, notice here that our left side is a product of x squared and sine x. And we can assign the first term as we have f and we have g. Therefore, our derivative d all over dx of x squared times sine y, and so kukunin natin yung derivative, is equal to the derivative d all over dx of 0. Next, by product rules, we have ito yung first term natin and second term. Again, first term, second term. We have first term, x squared, multiplied by d all over dx of the second term, which is sine y. Of course, addition po yung operation natin for product rule. And then, we have sine y multiplied by d all over dx of x squared is equal to the derivative of 0 is equal to 0. Next, evaluate then the derivative of sine y. So, we have copy x squared. Derivative of sine y is equal to cosine of y. Again, cosine of y dy all over dx. Again, nag-differentiate po tayo ng terms with variable y, kaya meron tayong dy all over dx. Plus, we have sine y times the derivative of x squared is 2x is equal to 0. Yung 2x po nakamultiply sa buong function ng sine y. Next, simplify then, we have x squared multiplied by cosine y dy all over dx plus 2x sine y is equal to 0. Next, transpose. So we have x squared cosine of y dy all over dx is equal to, from positive, that becomes negative 2x sine y. So we have divide all terms by the coefficient of dy all over dx. So i-copy lang natin. So we have x squared multiplied by cosine y dy all over dx is equal to negative 2x sine y. Divide all terms by the coefficient of dy all over dx, x squared cosine y, and then of course the right side with the same divisor, we have cosine y. Of course, we can cancel. So we have dy all over dx is equal to, ayan, so simplify na natin, negative 2x all over x squared. So, kakancel natin yung x sa taas and then natira is isang x sa baba. So, we have negative 2 all over x. Next, sine y all over cosine y is also equivalent to, okay, we have tangent of y. Therefore, dy all over dx is equal to negative 2 all over x tangent of y. Again, take note here that tangent of y is also equal to sine y all over sine y all over cosine y. So that is our third example. For our fourth example, the given equation is sine y equals 1 plus y ln of x. Again, get the derivative of all of the terms. So we have d all over dx of sine y is equal to d all over dx of 1 plus d all over dx of y multiplied by ln of x. Next, derivative of sine y is equal to cosine of y dy all over dx. So that is our derivative for the left side. Okay, next, derivative of a constant is equal to 0. Next, the derivative of the second term, since again this is a product po yan, y times ln of x. So first, this is your f, this is g. Okay, copy the first term, we have y times the derivative d all over dx of ln, natural logarithm of x, plus we have the natural logarithm of x, that is g, multiplied by dy all over dx of y. Next, copy lang natin yung left side. So we have cosine of y dy all over dx is equal to, we have y, derivative of ln of x is equal to 1 all over x. Okay, plus ln of x, or the natural logarithm of x, multiplied by, ano ba ang derivative ng y? So that is equal to 1. 1 times dy all over dx. Next, combining all terms with dy over dx on the left side. So we have cosine of y dy all over dx. And then ito, ililipat natin sa kabila so that becomes negative. Natural logarithm of x dy all over dx is equal to, natira sa right side is y all over x. Next, factor out dy all over dx. So we have dy all over dx of cosine of y minus the natural logarithm of x is equal to y all over x. Of course, we can divide all terms by, we have cosine of y minus ln of x. And then the same is true with the right side. So we have cosine of y minus ln of x. Next, cancel common terms or common factor. We have dy all over dx then is equal to y all over x. Next, kunin na natin yung reciprocal ng denominator. So that is multiplied by 1 all over cosine of y minus the natural logarithm of x. Therefore, and you can simplify further as dy all over dx is equal to y, yung buong numerator, all over distribute x to every term of the other factor. So we have x times cosine of y is x cosine of y minus x times ln of x is x ln x. Okay, so that is now our final answer. So those were our examples for differentiation or implicit differentiation. Now in this lesson, you learned that inverse trigonometric functions can be differentiated using the previously discussed differentiation rules. Next, if a function is defined implicitly or the variable cannot be expressed in terms of the variable x, implicit differentiation will be used to find its derivative. So, gaya ng sinabi natin kanina, for implicit differentiation, ginagamit natin yon kapag yung equation natin cannot be expressed in terms of x. And that is our lesson for today. I hope that you understood our lesson on the derivatives of inverse trigonometric functions as well as implicit differentiation. Thank you again for listening and mabuhay!